Section 4.3 is about logarithmic functions. So in the previous two sections, we talked about exponential functions. Exponential functions are of the form f of x equals a to the x. So your variable is in the exponent. A must be greater than 0 and a cannot equal 1. Logarithmic functions are the inverse of exponential functions. So logarithmic function is the inverse of an exponential function. And the basic logarithmic function is log base a of x. So a is called the base. And this is the basic definition of a logarithmic function. And you really want to know this definition. We're going to be using this in order to solve logarithmic functions and exponential functions. So the basic definition is that a has to be positive and a cannot equal 1, just like when we talked about exponential functions. And here's the basic definition. Log base a of x equals y means that a to the y equals x. Okay, so we're going to use that definition to solve some log equations. All right, so based on the definition, log base 2 of 8 means, okay, I can rewrite this in exponential form, 2 to the what power equals 8. 2 to the x equals 8. Well, we know that 2 to the third power is 8, so that means that x would be 3. So that means that this equation, log base 2 of 8, is equal to 3. Okay, now let's look at log base 4 of 1. So this is asking 4 to what power equals 1? Well, anything to the 0 power equals 1. So log base 4 of 1 is 0, and that's because 4 to the 0 power is 1. I'm just going to rewrite the definition. Okay, so all we're doing is rewriting these in exponential form to find the solution. Okay, let's look at log base 3 of the square root of 3. So what this is asking is 3 to what power equals the square root of 3? You can think of this, oops, dear. So the answer here is going to be 1/2, because 3 to the 1/2 power is the square root of 3. Okay, log base 7 of 7. 7 to what power is 7? 7 to the first power is 7. That means log base 7 of 7 is 1. And that is because 7 to the first power is 7. Okay, and lastly, let's look at log base 5 of 1 over 25. So 5 to the what power is 1 over 25? Well, we know that it's a reciprocal of 25. Okay, and 25 is 5 squared. So 5 to the negative 2, 5 to the negative 2 power is 1 over 25. So that means log base 5 of 1 over 25 equals -2. Right, and notice that all of these bases are greater than 0 and not equal to 1. Right, that's one of the requirements for the log function. A has to be greater than 0 and a cannot equal 1. All right, let's look at a few more. So we want to write these in exponential form. So we're given an entire equation. Log base 10 of 1,000 equals 3. We want to use the definition to write in exponential form. So let's just rewrite our definition. We know that log base a of x equals y means a to the y power equals x. So I'm just going to rewrite these. So log base 10 of 1,000 equals 3 means 10 to the third power equals 1,000. Okay, this is log form, and this is exponential form. Same equation, different ways of writing it. Okay, log base 2 of 32 equals 5. That means 2 to the 5th power equals 32. Okay, log base 10 of 0.1 equals -1. That means 10 to the -1 power equals 0.1. And then lastly, log base 16 of 4 equals 1/2. That means 4 to the 1/2 power equals 16. So this is really something where I kind of memorized the pattern. You have to know this definition inside and out in this chapter. Okay, in the next section, we're going to go the other way. So we're going to write it in log form. So let me just move this down a little. So we're given exponential form, and we want to rewrite this in log form. And again, you want to remember the definition. We're going to go backwards this time. So we know that log base a of x equals y means a to the y equals x. And we're going in this direction this time. We're starting with exponential form. We're changing to log form. Okay, so your base is the exponent base. So we want to write this as log base 4 of 0.125 equals -3/2. So remember that log, the whole purpose is to be able to find the exponent. So the answer is the exponent. Okay, if we look at 7 to the third power equals 343, and we write this in log form, that means log base 7 of 343 is 3. Okay, we're in base 7. That means that log base 7 of 343 is 3. Okay, these are the properties of logarithms, and you need to write these down and have these in your notes. Okay, so log base a, so log base anything of 1 is always 0. Okay, and the reason is because anything to the 0 power is always 1. Okay, so log base anything of 1 is always 0. Okay, the next one is log base a of a. Okay, so your base and the number you're taking the log of are the same. That is equal to 1. The reason for that is because anything to the first power is itself. Okay? Next we have log base a of a to the x equals x. So log base a of a, those kind of cancel and you're left with just the x. The reason is if you rewrite this in exponential form, you have a, right, the base to the exponent equals a to the x, which is always true, right? So the log base a of a, that part kind of cancels. You're left with just the exponent. Okay, and these two are kind of similar. So a to the log base a power, those are inverses, so those cancel, and we end up with just x. The reason is if we wrote this in log form, okay, so log, here's my exponent base, log base a of x equals this exponent here, log base a of x, which is always true. Okay, so a to the log a, those are going to cancel. You really want to know these because these are shortcuts. Okay, and next we're going to talk about common logs. So common logs means base 10. So if you don't see a base written here, okay, some of the other problems we've looked at have, you know, log base 2 of 8. We know that's 3. We don't see a base written here. If you don't see a base, you assume it's 10. Okay, so common log is base 10. No base written, you assume it's 10. You can fill in the 10 if that helps you, but log base anything of 1 is 0, right? It's the same reasons we just talked about in the last slide, because anything to the 0 power is 1. Log base 10 of 10 is 1, right? Because log base a of a is always 1. 10 to the 1 is 10. So these are really the same properties of the previous page, just showing it with common logs. And then log base 10 of 10 to the y equals y. And then 10 to the log x equals x. You just want to remember, if you don't see anything there, you know it's really base 10. Okay.